Okay, hello, welcome to this Couchbase Hangouts on Air. We are going to be looking at Couchbase 4.0 today. And so I'm Matthew Revell, and with me is Cihan from our product management team. Cihan's been looking after all the work on Server 4.0. Hey, how you doing?
Very good, Matt.
Cool.
This is Cihan Biyikoglu. I'm in product management here at Couchbase, and like Matt said, I look after Couchbase Server.
Great, and you're in the East Bay, right? So it's quite early for you in the morning, isn't it?
I am. I can see a little bit of light coming out just about now. But yes, I've got coffee though, so I'll be awake.
Okay. Well, that's good. So I'm in for anyone who cares, I'm in Staffordshire in England. So we're conducting this hangout over about 6,500 miles of space, so that's quite interesting. Okay, so what we're going to look at today, you might have already heard about some of the things in Couchbase 4.0. So this is a chance to ask questions and to find out more of the detail and kind of the process that led to where we are right now. So Couchbase 4.0 is our next major release, as you might have guessed, and we're looking to get feedback and an understanding of how it's working out for you as developers. Right now we've just recently released the developer preview. Is that right, Cihan?
That's right. A couple of weeks ago, we pushed it out the door. There's a beta 1 coming in a couple of weeks as well. So I'll break that news here.
Great. Okay, and so our process is basically we put out a developer preview, we get out the beta, and then we'll be looking for general availability, I guess, later this year.
Yeah.
All right, great. So the 4.0 headlines are really, I mean, if you're interested in Couchbase at all, you can't have helped but see something about Nickel, which has also been described as SQL for documents, you know, as a kind of a tagline, I guess. But Nickel is the big story. Then there's secondary indexing, and also ForestDB is a new kind of data storage layer for on disk data. So I'd like to kick off really with first off, is that pretty much, are those pretty much the headlines for 4.0?
That actually covers a whole lot of the set of things that we've actually put in. Just the journey up to here is kind of an interesting one, because Nickel has been in development for quite some time. So some of the pieces that you're talking about really have been in development over a year, with the query execution engine, with secondary indexing. Some of those are really components that have been maturing alongside of 2.5 and 3.0, if anybody has memory of that history. But those two components are really core to it. There's a couple more unique things. I'll kind of talk about a few more headlines, just the next click down. So we've done a lot of security enhancements on the product as well. That's something I have to mention, otherwise I'll get a hard time from some of the other PMs I have in my team. And security is critically important to us, and when it comes to compliance and simplifying that process, it is really important. So if you're trying to deploy something into an environment that has compliance requirements, either internally or externally imposed, it really helps simplify that process for you. There is a number of improvements on XDCR, cross data center replication capabilities. And one of the fundamental changes we're doing, we have done a lot of architectural changes in the previous version of the product that actually did set up a lot of these capabilities that we're bringing in now. So things like the IO subsystem, for example, was completely redone in 3.0. It uses a completely different technique. There's a pool of threads, etc. The memory management subsystem is actually quite different in how it manages memory under large memory. That we have some additional dials and settings that people can play with. And then the replication protocol got updated. So all three really are setting up secondary indexing and Nickel and some of the enhancements there. But the fundamental change in 4.0 around topology architecture is how we actually allow deployments to work in 4.0. We're calling this multi-dimensional scalability, MDS for short.
Right.
And MDS is kind of an interesting model for scaling out these variety of workloads that we have to tackle within the environment. So there's all the things you know from 3.0, the key value interface, that the core data operations. And typically indexing will run across that on all the nodes that you deploy in homogeneously kind of sliced up way across all the nodes. You'll have query workload running as well on top of it that will run across every node, typically in every database. And you can do that with Couchbase too. I mean, Views pretty much did that for you in the past. And with 4.0, you can continue to do that. But we're bringing a new model, that allows you to isolate these workloads and prevent competition among them, to allow you to minimize jitter, allow you to have much better control over how you scale some of these things. And the interesting thing about this is when you think about how core data operations work, or when you think about how indexing and query works, sometimes we've kind of taken scale out and really applied that to every workload that we have in the database. But it's scale model. When you look at these individual workloads for query and indexing, they don't really benefit the same way as the core data operations would when you add just another node. The scale model isn't as linear. So this is one of the important things I know that sometimes gets lost, but the multi-dimensional scalability, this new topology of being able to deploy these services in the past, that's another important headline that's there.
Okay.
There's a laundry list of other things that we're doing, but I'll stop there, and I think those really construct the top headlines.
All right, so I mean that's great. Thanks. I'd like to go back to the multi-dimensional scaling in a minute, because it's one of those things that kind of sounds perhaps. So for a long time we've spoken about having a single node type and so on, and now we're offering lots of different or a couple of different node types. And I'd like to go into why, when that makes sense, but maybe after we've looked at SQL for Documents and the indexing. So SQL for Documents. So this whole kind of thing that we're involved in right now is typically called NoSQL, and suddenly we're introducing Nickel, which we've like I say, kind of taglined as SQL for Documents, but we've got this Nickel language. What's the story there? Why are we going back to SQL?
Why are we going back to SQL? That's a great question, and it's not the first time I got that question, but it is I think an important one, and I think if you look at across these two worlds and how we got to this decision, there's a lot of things that are good in the SQL world, and one of them is the ability to kind of query data with this expressive language. So I'm a little younger than SQL, I have to say. So SQL is a very old language, and it's been longer than I have in theory in this world. But if you think about all the other languages that we worked at, I don't think you're old enough to remember some of them. But if you remember, COBOL or PL1 or Fortran or any of these languages, we don't hear about them these days, right? SQL, though, was something that I used back then, and I still use it today. It is one of those languages that really lived on. It is a very expressive way to manipulate data, and it's been successful, I think, in a number of different ways. So one of the things we wanted to do really was with this technology was really bring that in, because I think SQL is an extremely expressive language. So we're embedding, if you want to think of this, we're embedding a SQL gene inside NoSQL by bringing in the Nickel language in there. It does a couple of things, and this is what we found, is that one of them is a lot of people are they have to live in a hybrid world. It's not that there are many choices for your data applications, and I've worked on quite a few of these databases myself, from Illustrator and Formix to SQL Server. And what ends up happening is a lot of us that have been around for a while we actually understand SQL, and there are cases where you kind of have a hybrid environment. You either have applications that are legacy that are still using that platform, but you still have to deal with the new world. And SQL language really allows you to transition fairly easily from one to the other. We'll take a look at, if you guys are interested, into some of the language specifics, and it really looks extremely familiar. And there's a very large crowd, myself included, that understand SQL fairly well. We've seen this movement in the Hadoop world as well. If you think about Hive, if you think about Spark, if you think about all of these languages that are kind of bringing back SQL, it's really in a convenient way, on top of MapReduce even, to really express what you're trying to do to the system. Another important aspect for us was really bridging the old and the new with this language. What is interesting about Nickel is, even though it is SQL, it is quite different in many of the ways it actually operates. One of the fundamental ways it is different from relational SQL is the fact that it actually returns JSON, not rows and columns. But the thing is, translating it down to this kind of more primitive rows and columns type result set actually gets a little easier. Once you're in the SQL language, expressing what you want is fairly close. If you think about SQL 92 versus Nickel, it's not 100 miles apart. It is really a set of differences that will allow you to kind of work and operate on very powerful data sets that are in JSON that really have a lot of interesting capabilities, like embedding subdocuments or arrays and a lot of powerful data types. But it also bridges this gap back into SQL, both in the way it communicates back results and both in the way that you express the query. So what it actually brought in with Nickel is we brought in a very native way for you to talk to it if you live in the rows and columns world. Mm-hmm. So if you are in Tableau or in Excel or in business objects, and you want to type in a query that will return rows and columns, there's an ODBC and JDBC driver that does a small sliver of translation back and forth, but could translate things back into rows and columns, which a lot of tools continue to understand. There's a large investment in that world. So going back to the basics, it was an expressive language. It is something that a lot of people know, and it really helped us bridge a gap that exists today, which is the world of JSON and document databases and complex multi-model databases that can express a lot, versus the relational databases that have kind of over 30 years built an ecosystem of tools that really work with rows and columns. So those three really ultimately were the things.
So, SQL is based around ideas of normalization, or expectations of normalization anyway, and like you say, around a rows and columns model. So how do you take that and make it appropriate for a JSON semi-structured world where normalization just isn't a concern?
Isn't a concern, yeah. It is. The data modeling and how you express and reshape the data is also very powerful with SQL. So one of the things that maybe is a bit of a misnomer in the world of JSON and document databases is that there isn't any normalization, but there still is, right? You still have, the reality is you want to express the real world and what you program against with full fidelity into the database, and JSON allows you to do that. So there are objects that are extremely complicated. They're not just rows and columns, and something like a catalog entry or something like a profile of a product or profile of a person that's living in a system. All of these things are fairly complicated structures, but combining them in, let's say, products and customers are not things that you normally combine. So there's some level of normalization. Obviously, you never end up with a single ginormous table that represents everything. And Nickel, the power of Nickel is it allows you to combine these documents, even if you actually end up with some of these types of normalizations, either because they're truly separate entities in your app and you have to manipulate them separately, or they happen to be things that you'd like to normalize for other type of optimizations that you want to make. Let's say I think there was a forum post the other day on Couchbase forums about chats, chat windows and chat rooms and individuals, for example, right? Whether you actually embed the chat room into individuals' private messages that are exchanges between the two individuals, or whether you actually make them separate objects. These are kind of interesting questions to play with, but I can see both options kind of working. So the power of Nickel, I guess, in this model is it gives you and protects this full flexibility you have in your data model, whether to normalize or denormalize. And it still allows you to combine these multiple documents back into a single document and a single result set at the end. So if you had, I'll continue using that example. If you have individuals and chat rooms that are one-on-one between individuals, even if they are separate objects, you can actually combine them into one while you're returning the result set. There's no reason for your app to grab one, grab the other, and do some client-side processing to do all of that. And I think it's one of those things that highlight how SQL can be powerful to reshape the output on the server side without the client side having to do a whole lot of work and simplify this work.
Right.
Yeah, and I think, I mean, there's a thread of other things where the language is extremely expressive. There's so many functions that you can express. There's data types, obviously, the standard JSON data types that you can work with that allow you to manipulate an array or insert an item or delete an item out of an array or take an array and pivot that into a set of rows or a set of rows into an array. And all of these are interesting manipulations when it comes to the world of JSON and flexible data types and documents in general. And Nickel is built to be able to do all of those things.
Okay, good. So, I mean, it feels like we're moving beyond the early days of NoSQL when the answer to the question of how do I query this or how to do anything beyond key value was it's all in the client layer. Whereas now we're moving it, actually, we're providing some more expressivity in the database management system itself. So that's good. I'm really keen to see it in action. Can you give us a bit of a demo?
Absolutely, happy to do that. Let me just plunge into this, and I'll share my screen quickly here. Can you see this?
Yeah.
Excellent. Oh, it looks like I've got some workload running here, but let me start with a very quick tour of what the environment looks like. This should look familiar if you've used Couchbase before. This is our administrative portal. And the admin tool essentially allows you to do basic operational work, but a couple of things that are interesting that I'll highlight, and then we'll dive right into Nickel. One of the things is this is the server nodes tab at the top. This is where you see the list of nodes and how they're doing. The status is reported here. I happen to be running this in the cloud, and I have 6 nodes here. The interesting new thing to look at is data. The service type on each node is different, and data service happens to be the core data operations that we talked about. So in a way, there's multiple deployment models with Couchbase Server, and you can certainly have data, index, and query on all the nodes, which is what we talked about as kind of the homogeneous scale-out model. Every node can do everything, and they will get an equal share of the work, and et cetera, et cetera. But in this model, there's an alternative. In Couchbase Server 4.0, there is a new model of deployment where you can isolate these services and control their capacity very with kind of great precision. And in this case, what I've done is just a sample. It doesn't have to be this way, but I've got 4 data nodes that actually do all my core data operations. These are key value operations that it's the regular insert, update, delete operations. And they're a fairly small set of nodes. In terms of hardware, these have half the cores of the next 2 machines that contain the index service and the query service. So the index service and query service, when they scale up, they love the fact that they can get access to more memory that's local, as opposed to doing scatter gathers. or query node will actually love the fact that it has access to more cores within a machine, and it can do a lot more local parallelization. Because of that, what I've done is I've added nodes that actually have twice the capacity of RAM and twice the capacity of cores for index and query nodes, and I've assigned these nodes specific services. Here's how you do that, just really briefly. It's very simple. When you're adding a node, you get the option to check which services you want to enable or disable, and every combination works. So typically, you'll either do this, or you will select one of these services on that node, and you can run it. And the idea is that every node continues to be the same. It's just you assign dynamically what specific role you want that node to play within the environment. So in this case, I'm asking this node to play a query service role. And that really essentially means that my query workload is just going to go to that node for now. But I can change my mind. I can, just like before, I can remove a node, and I can change its role essentially through a process like that. So let me kick into SQL for Documents. These are the nodes that are the 6 nodes that are running my Couchbase server here, and this is a window that has CBQ open. So the CBQ engine is what the query engine process is called. This runs on the server, and it essentially, Couchbase Query is essentially the process that allows you to submit SQL queries. The tool itself will take SQL queries, submit that to the service, and will allow you to interact with it just like any other relational database. If you had direct query interfaces, this is kind of that tool. So I can run things like select star from system key spaces, and I'll get a result. And it turns out there's only one key space here called default, and that's the key space. I should explain this too. The key space refers to a bucket, and the default bucket is what I actually have here. If I can look at some additional system information, like what type of indexes exist on this environment. It turns out there are 8 indexes here, and they all happen to be kind of on the default bucket and on a variety of different things.
So why have we changed that? Why are we calling them key spaces and not buckets here?
That's a good question. So we want it to be a little more generic, and we're essentially, if you think about this, we're trying to keep a door open in future about what we map key spaces to be. So in future, and I don't want to reveal too much about how we're thinking through this, but buckets are generally design services that allow you to put many different data types in, and we'd like to continue on that route. The buckets continue to be bags that you can actually put in a lot of different types of information. There's no reason, unless there's this specific optimization you're chasing, there's no reason to kind of separate the users from the products, right? You can actually put all of those into a bucket, but key spaces could be mapped into a variety of different things, and with the naming notation, it's going to allow us to kind of be future-proof, if you want, on some of the changes we want to do in the future. That's really what it is, and that's the reason for it. We'll try to make sure we explain some of those things really, really clearly in the documentation. And yes, until the future arrives, some of this is not going to seem extremely meaningful. But if I wanted to run a couple of queries, like let's run a query on default where, and I actually don't know if I have a lot of meaningful data in this, but I actually may not get anything back for this, but just for kicks, I'll show you what the syntax looks like. This is what a syntax for nickel looks like. I hope you guys can see what I'm highlighting here, but hopefully you can't really tell the difference between nickel and a SQL query, and hopefully that is a good thing for you. It really looks, feels, smells a lot like SQL, relational SQL. All I'm doing is giving it the bucket itself in the from clause, and filtering based on the attributes that may or may not exist in every document. Type may or may not exist inside this this environment. In the default bucket, there may not be an attribute called type on any of the things that exist. But the language is forgiving for it to be flexible. So it will look across the entire data set to see if there's anything called type equals beer with this. Now, one of the interesting things I can do also is not only can I actually run queries like this, but I can also get some visibility under the hood into what exactly it will do to get to this answer. So explain, if you're familiar with things like profilers that actually allow you to kind of peek into what the execution looks like, explain does that. So let's start with that. This is an execution plan for this statement that is coming in, and it is, not surprisingly, coming back with the JSON result. It starts with a couple of operators. It turns out it's going to do a primary index scan on an index called I2, and it will essentially parallelize a set of operations called fetch and filter. So what it is doing is, I have no index that is meaningful for this operation, so it will essentially do an entire bucket scan, if you wanna call it that, and it will fetch these results and try to filter for beer in type attribute in the document, and then it will project. The projection really just is a set of columns that it wants to spit out, and it will finish execution of this query. So from hopefully look and feel and from explanations, you can see that this feels very familiar to SQL. If you work with SQL, this is kind of quite easy to work with. If you're not a SQL person, and some of us are not, then you don't have to work with SQL. There's obviously many abstractions above SQL that you can work with, things like Ottoman, which I'm sure will come into a chat, a webcast like this near you fairly soon.
Yeah.
Which allow
that's
you.
ODM for Node.js, right?
That's right. That's right. So depending on the language, or if you're a Link fan and you really like to abstract away from SQL in your language and really want to kind of pull up a level, all of those possibilities are there. And as I said, SQL for people who like SQL is great. For people who want to stay away from it and want to kind of work in the world of abstract objects and natively kind of communicating, Nickel also is a great method because it keeps that full fidelity JSON communication back and forth. So the translation that happens between the two is minimized. It just happens to be the way in which you express the query back into the server, and it is a very powerful one. Now, sorry, go ahead.
I was going to say the query you just did the explain on sounded quite expensive if you're going to do a full bucket scan. So I mean, if I had quite a number of documents in there, that would sound quite inefficient. So how do we get around that?
That's a good one. So one of the things you can do is run a create index statement that will optimize this query. So let me just kind of go back and maybe I'll do this. So remember, this is our statements. Select star from default where type equals beer. So what would benefit this query is very obvious, is an index on type. And I could either create an index on type equals beer and only index the things that really are relevant to this query, and that would be extremely efficient. Or I could index the entire attribute of type in my bucket. And if my next query happens to be not on beer but breweries, it will pick up that index and it will run with it. So one of the statements that you can actually run is create index. And this allows you to create the indexes and kind of pre-compute essentially a optimized results that allows you to make this filter work extremely fast. And let's call this beer filter, or let's if I can spell, beer index. And we'll create this on the default bucket on the type field. Now, there's a couple of attributes you can specify. One of them is called using GSI. And GSI is the new indexer that we're introducing. It's the secondary indexing that allows you to index extremely effectively. We continue to provide the views option for you. So if you really wanted to use views as your indexer, you can continue to do that with Nickel as well. So Nickel has these two options, and the main difference, that there's a lot of things that are different about them, but the main difference is the way in which they partition in the 4.0 timeframe. So if you use views, you're going to be living in the data service. You are going to be distributed very much aligned to the way the data is distributed. So your view is going to be planted right next to each node that runs the data service. And on each one of those nodes, locally, you're going to create this index, the partition of that index. In the case of GSI, you're going to live on an index service node, which was one of the nodes on our case. And it is going to be an index that will give you full continuity on that node. So that single node can actually contain everything on that index. And without scatter gather, I can actually answer this question of, can I look up every type that is equals to beer, get the list of keys and just look them up. Because I'm doing a select star, I have to kind of go back and bring the actual documents back. But essentially that process of being able to look up happens extremely fast by looking up that index. There are a variety of type of queries that work really well with GSI, and we're going to have that's a whole separate conversation about how you actually use these index types. But the new indexer is optimized for these type of secondary lookups, and it has got strong caching and storage engine, etc. that lies underneath it that makes it extremely powerful compared to views too. So this is a statement that you could run. I'm going to try it. I actually have an experiment running, I believe, on this in the background. So I'm not really sure if this is going to succeed here. But the create index statement ultimately is the way in which you kind of create new indexes, and you can express that to the system. Now, one of the other things I wanted to show, let me kind of do something here, and I think you guys are seeing kind of a system that's still in development. So I don't know if this statement is going to come back. Okay, so yeah, I think I've got some load running on the system, so I may actually have to just go back to the old state. Let me do this.
Just while that's happening, what's so we're used to views in Couchbase being running at a slight lag behind the current state of the documents themselves. Yes. Is that the same case with GSI?
Great question. Yes. So with GSI, you continue to be able to express, and with Nickel, really, you continue to be able to express the same consistency model you had with Couchbase, which is, you can either do things in memory and you can do the core data operation and leave without having to maintain the indexes. So the indexes can be eventually consistent. Or you can express to the system a type of query that will actually wait until a specific level of consistency is reached. The great thing about Nickel is not only does it give you the ability to express consistency in kind of these coarse terms that we allowed you to do things in views, which was, you could say stale equals okay, and you could say essentially, I want to query whatever is there, right? I actually make an insert, and when I query whatever is there, it may or may not be in the mix, right? I have no guarantees, and stale equals okay essentially express that to the system. Or there was another kind of meaningful click stop on the consistency model, which was essentially strict consistency, where you could say stale equals false, where you essentially said, no, up to the moment of this request, I want everything to be indexed, and then I want my query to start. So we captured the timestamp of your query, waited until the index caught up to it, and then run your query. And these two you can continue to express to the system. But with secondary indexes in Nickel, you get the ability to do things a lot more granularly, and the shades of gray that you want to express between the two exist. So if you imagine a case where you could say, well, I'd like to insert a new value, and pick the timestamp of that insert operation and pass that into a query, you can actually not only express an unbounded consistency, which is whatever you have, or very strict consistency. You can actually express something in the middle that allows you to do read your own write semantics in the system. So you can say, look, I made an insert 10 milliseconds ago, and I'd like the query consistency to be at 10 milliseconds ago, which essentially gives you 10 milliseconds worth of indexes or operations that can be saved. So you have essentially saved 10 milliseconds on not having to wait for all the operations that may have happened, plus all the things that we had to index during that time don't have to be indexed. And that adds up to, I guess Couchbase can do a lot of things in 10 milliseconds, and that could add up to a large amount of operations and indexing that you can skip. And that translates back into query latency. So essentially, it means by expressing read your own write, you can get a much better latency, but the consistency that you actually want out of the system. And as you kind of relax things more, you can get more and more of these efficiencies from the system. So it does really bring in a lot of interesting capabilities on the consistency model as well. Let me add a simple bucket, and we'll stop the workload from running, so we can actually do some little experimentation here. So there's the beer sample bucket, and now I have the beer sample bucket here. The query that we were trying to run was like start from sys. Sorry. This was the query that we were trying to run, and let me see if we actually get an error message. So let me create a primary index first.
So is that a configuration option where you can reject queries that don't have an index associated with them?
It is, yes. This is actually the mechanics of exactly that. So in the case of beer sample, if you want to run an ad hoc query where you may not necessarily have an index underlying it, but you really like to be able to kind of do scans in these type of buckets, and there may be small buckets that where this may be perfectly appropriate. We require that you have something called a primary index. A primary index essentially is the list of keys, document keys that exist in this bucket. And it allows Nickel to be able to operate any type of query on this bucket. And that's the index that it is asking for. It essentially says there is no index for me to use for type equals beer. There's no index for me to use to do a full scan on this bucket. So you need to give me one index at least to be able to kind of do this operation. And that's what the primary index really provides. And I'll actually add this in. So this happens to be an index, much like the one that we had on default, that essentially indexes every document key and puts that on a GSI index, a global secondary index, and puts that on the indexing service node. Let's see if my demo gods are with us, and this will actually come back with anything. Yeah, it looks like my environment really operate all that well. So I'll give up on this demo, I guess. At this point, you guys have seen at least some of the statements, but somehow I think. But just to kind of carry on with the thread, the operation I wanted to show you guys was creating the secondary index on essentially that allowed us to kind of do something like this, the beer index that would allow us to index type beer. Or I really wanted to demonstrate the fact that you could actually do something like filter on an index that allowed you to just index a specific subset of data. So if you've got type beer and type brewery, you could create indexes that really sniper shoot a specific subset of data within a bucket. And this filtration allows you to be very effective in kind of creating the indexes. Unfortunately, in this environment, I seem to have something going on with my experiment that doesn't allow me to create the indexes at this point. So yeah.
We touched on it a little bit earlier, but how do you decide when to use a view and when to use a GSI?
That is a great question. So there is a couple of differences between them that really are important to remember. I think one of them is how they're partitioned is fundamentally different. GSI is global secondary indexes have, as an indexer, will actually be optimized and will actually create an index that isn't that can reside essentially on the index service. The property of the index service is the fact that it can be pushed aside to a subset of the nodes in a zone within the cluster, just like the setup that I was showing, where you could actually have a subset of the nodes assigned to that index. Versus views, the way they're distributed is they're aligned to the data and how the data is distributed across the cluster. So if you've got 50 nodes that are running your data service, your index is going to be sliced up identical to the data and will be placed that way. Another difference, so this is one fundamental difference between the two, and how it answers a query or how it builds the index based on this partitioning model is fundamentally different, right? If you imagine what we need to do is one of the operations we have to do for an index, obviously, is to maintain that index. And in the case of views, just to kind of look at why this distribution is interesting, in the case of indexes, we have to shoot, and there's a architectural addition to the data service that allows us to be extremely effective in what we shoot, but we have to shoot the changes across the cluster to the index service node if you actually place that on a separate node. In the case of views, the changes never leave the node that you're running on because the data and the index, the data and the view, the indexer that is maintaining the view, they live on the same node. So the maintenance operation is extremely fast. But when it comes to querying, something interesting happens when you ask questions like, well, I'm looking for matt@couchbase.com as the email address, which doesn't happen to be the document key, but it happens to be a secondary index that exists. So either you created a view using the view indexer, or you created an index using the GSI indexer. But in those two cases, how we answer that query based on the specific index you created is very different. In the case of views, let me describe that first. When I asked that question about email equals matt@couchbase.com, I essentially have to ask that question to every one of the 15 nodes in my cluster, because I really don't know what the partitioning scheme is. The partitioning scheme is based on the document key, not on the email address, so I can't really infer anything. So that's a scatter-gather that has to happen. In the case of a GSI index, because the partitioning is controlled and the indexing service is where that lives, I can be very intelligent about which node and which specific index to go to, and I can do that without this scatter-gather that is fairly slow and across the network. So it allows me to do a local scan of that index to find if there is an email address that has matt@couchbase.com and return the answer immediately to query service. So you can see how the partitioning really makes a huge amount of difference, both in how we maintain the index and how we query. Another difference between them is how we actually cache them. So Views depend on CouchStore as kind of the storage engine. And the new indexing strategy that we brought in uses our new storage engine, which is going to eventually bleed into all the other components too. But we're starting with the GSI indexer. And what it allows us to do with this ForestDB engine is we have much better, much more native caching and much smarter caching of the indexes themselves in memory, versus views will use kind of CouchStore, and essentially what they depend on is the file system cache for the most part when you actually run a query. So there could be things that are not as sensitive to how you query the data, for example, when the caching happens on views, versus the GSI caching that happens through ForestDB is a lot more smarter about how to do these things.
So ForestDB is the new on-disk storage engine that we're introducing in 4.0. We're only using it for indexes right now, but it will roll out to more things, you're saying?
It will roll out to more things in future. In 4.0, the only component that takes advantage of ForestDB will be the GSI indexing capability. But in future, yes, we will bring that into the other components. So that's another fundamental difference between them as to how they actually their storage engine and their memory management is fundamentally different when it comes to views and indexes. And because of that, you will see differences in response times to queries and differences in how they actually maintain. Another important thing is what you can express with views versus indexes. So there's actually something advantages in views, which is indexes do not come with reducers. So they are much like the relational world, where they're really about secondary lookups and optimizing scans, but they're not about pre-computing results like aggregations or groupings, versus views can actually provide you that. So there's still a lot of cases where you may actually want to choose views because you have aggregations, you have reducers, and you have JavaScript complexity and expressiveness that you can use to create that view. But then if it is fundamentally, I guess, if it is a straightforward lookup case or a scan that you want to do on an attribute, GSI is the new indexing mechanism that really is much more effective for that. So hopefully that gives you a couple of the things. There's a lot to peel back on all those two things to really detail them, but these couple of things are the differences between them.
Okay, great. So very briefly, with the new multiple node types, I'm guessing when you're kind of starting out with the Couchbase cluster, you'd just do what we do now and have a single node type. But perhaps as you grow or as you learn more about your data access patterns, you might want to specialize. I mean, do we have recommendations? Yeah, I know it's early days, but do we have recommendations for how people should select those node types and move beyond that single node type?
Yeah. So fundamentally, the way in which you can deploy a cluster between 3.0 and 4.0 does not change. If you don't want to do anything special, if you're not sensitive to latencies in your application, if it is not a case where you really don't care whether it's sub-millisecond or 1 millisecond latency or etc. Right? If you're in that mode where today things are working fine and you're really not you're okay with the way things operate within your cluster, you can continue to use this single node type and single deployment model strategy. What we'll do is we'll place every node with all three services. It's going to look like every node does exactly the same set of operations, and same services will run across them. When you create your indexes, we're going to or views, we're going to use all of those nodes. When you create your index, we're going to round robin on which index node gets used for the indexes. But ultimately, you're essentially landing on a system that looks very much like what you can do today with Couchbase 3.0. Each node gets an equal share of the work. As you scale out, you distribute that load. In the new world of 4.0, the option you gain is the ability to say, take the indexing and the query workloads and put them on a separate node. And how you can shape that and what the best practices are is still something that we're kind of working on articulating. But essentially what's emerged with a lot of the cases is if you have queries and indexes that are of certain type that are like the ones that we looked at, where you're looking up by email, or you're looking up, you're looking at a short range, or you're looking at a range of rows, range of items that really contain a specific attribute. When you want to process things like that are not aligned to the distribution, you actually want to separate those services out to separate nodes. What it gives you also is a lot less interference with your core data operations. What happens in a database is, as you shoot a fire hose of insert, update, and delete operations that are setting the keys, right? There is a background workload that is required to maintain the index, and every node is trying to do both. So what happens is, as you throw in more insert, update, deletes, there's the index load that's pressuring, and that puts a bit of a pressure on the incoming data workload that is coming in. So what essentially happens is, as you create more indexes, your core data operations start slowing down because there is competition on every node. And as you kind of burst into different types of loads, you'll see that burst kind of create reactions that in the indexing and in the storage engine. And in the case of this isolated topology, where you have data service and index service and query service isolated, what you see is that burst and the dedicated set of capacity that you've reserved for the data service can actually happen a lot smoothly without a lot of jitter. So a lot of that data can, without competition, can continue to get appended to the bucket, right? Added to the bucket, and those operations are received. But the indexing happens on the side on a dedicated set of nodes, and that means that you can isolate this competition and put that on the side, and it gives you much smoother. We're not done with completing this software development cycle, so I shouldn't. I don't have numbers to report, etc. But it ultimately results in a much smoother operation, and it gives us the ability to over-index. I don't know if that term makes a lot of sense to a lot of people, but over-indexing essentially is in database design. I've done this on a number of different documentations I've created in the past for a variety of products. Is what you end up saying is, you essentially say, look, there's a trade-off between how fast you can query and how fast you can insert. Because as you create indexes, either your insert, update, delete operations will get slower, or if you don't create enough indexes, your queries will get slower because they're not going to have an index that they can depend on. And in our case, with this isolated model of deployment, what we can give you is a mechanism that allows you to over-index. So you don't have to play that trade-off as bad as in other cases. What you can do is you can create all the indexes that are required to run your queries fast, but we can isolate their impact on the core data operations. So it ends up being that you can create a lot more indexes without having to impact your core data operations. And you can still run a lot of fast queries because you have the required indexes in the background to run those queries effectively. So I know this takes a little bit of explaining, but essentially this isolated model of data index and query service separation really is very unique in how it isolates and how it allows you to kind of scale the type of indexing and type of query you want to do independent of the core workload. And it gives you this trade-off you never could break away from, that essentially said, you do not create a lot of indexes. It actually breaks away from that limitation and essentially gives you much more freedom as to what type of indexes you want to create, and still maintain a very, very effective set of core data operations to do.
Great, thanks. We're actually coming up to the end of the hour, so I'd just like to say, if people want to get hold of it, it's couchbase.com/download, and then if you click on pre-release, you'll see the links for the 4.0 developer preview binaries. Cihan, is there anything else we haven't covered that you want to just mention in the last couple of minutes?
There's only one thing. So I'll just do this plug very quickly. we're obviously still in development, and I have the opportunity to make a change to this product still. So if you have feedback, you can certainly be the one to impact the final course of this product. And I'd love to hear from everybody who is looking at Couchbase about what they think about our query language, about our indexing, about the experience of this product and multidimensional scale. So it's your opportunity to download it, give us feedback, and we promise we'll actually listen and see if we can make changes that accommodate a lot of the users. Once we release the product, it gets a little harder to do some of those changes. So I want to offer up this opportunity to say, you guys can impact what we do next, and I'd encourage everyone to do that by downloading and playing with the product.
Great, thanks. Yeah, so couchbase.com/download and then click on pre-release. Okay, so thanks very much, Cihan. Really looking forward to seeing how 4.0 develops over the next couple of months. Also, look, if you have any questions about Couchbase generally or specifically about 4.0, forums.couchbase.com is a really great place to go. Cihan's there, I'm there, lots of people from the Couchbase team are there to answer your questions. Also, if you're in the States, Couchbase Connect is at the beginning of June in Santa Clara at the Levi Stadium. So go along to the couchbase.com website, you'll see links there, and you'll be able to actually just come up to us and ask us plenty of questions about Couchbase generally. Yeah, we'll both be there. So yeah, thank you very much for your time today, and see you on another Hangout. Cheers.
Thank you.